In this video, I'm going to be using two equations. The first will be E equals hv, and then I will be using the wavelength formula, wavelength equals c over v. This is a nice combo problem that I found in the book. It's problem number 53. So the first part of the problem says a photon has an energy of 1.10 times 10 to the negative 13th joules. So I know I'll be using the energy formula. So I'm going to go ahead and write out all of the variables and fill in what I do know. So I am solving for frequency in this first part, and the reason I'm doing that is then I'll be able to use frequency, plug it back into this second equation to solve for wavelength, which is the real question here. So I'm going to check my units and make sure these look good. I have my energy in joules, and my H, Planck's constant, which is a given, always provided for you, is in joules per second. So the joules will cancel out. No conversions needed before we start the problem. Now, the formula is E equals hv. I am solving for v, so I'm going to divide both sides by h. So this is really the setup I'm about to use, and I'm going to write it right down here, and then I'm going to plug in my values. And once I have it all set up, I will enter in my calculator, and for this part of the problem I will get 1.66 times 10 to the 20th. And my value, my units, is s minus 1. Okay, so that is step 1, solving for v. Step 2 is solving for wavelength. So I have my formula, I have all my givens, and I'm just going to go ahead and plug them in. C is the speed of light. It will always be provided for you. The units is meters per second. And then the value for v, or frequency, is what I found from the first part of this problem. When I go ahead and set this up, I'll see that my seconds are going to cancel out, which is what I want. I'm going to plug it into my calculator, and I get 1.81 times 10 to the negative 12th meters. So that is my second answer. And my third answer, they said, what kind of waves are these? So go ahead and pull out an electromagnetic spectrum sheet from class or from the book, and then you can find this value on the electromagnetic spectrum, and you will see that it matches up with a wavelength of a gamma ray. So that is the last part of the question.